Continual learning is the only research interest I've ever had, and basically it's the human learning problem. How do people start with just one brain and then spend their entire lives learning and are able to learn more and more and more sophisticated skills and knowledge? So if we were going to do that in a robot, what would be the algorithm or process that we would put into that robot at its inception to allow it, without any further internal manipulation, to learn forever more and more sophisticated skills and knowledge and develop a more and more sophisticated understanding of the world that it lives in? I'm very, very enthusiastic about, very excited about how much sudden growth, sudden enthusiasm for continual learning there's been. So when I started working on continual learning almost 30 years ago, no one was interested in it, and it was impossible to get anybody interested in it. In fact, it was almost impossible to get people to understand what it was. Even just a couple years ago, we had a workshop at NIPS 2016. It was attended by, I don't know, less than 100 people. And this year we had somewhere between 400 and 500 people on average, and peaking up to probably close to 800 people in the workshop. So enthusiasm for continual learning is exploding, and that I find to be fantastic. There are many, many more real-world applications for reinforcement learning because we have reinforcement learning technology already developed, and many different methods for attacking relatively simple reinforcement learning problems and making great progress on them, and getting excellent results. So that means that we can apply that technology pretty easily to a large number of different potential industrial applications. The easiest, the lowest hanging fruit is probably process control of some kind, I would say. And that could be engine optimization or power grid optimization, network optimization, places where decisions need to be made very, very fast, and small improvements are going to be very valuable for the business that is implementing those applications. Continual learning is still, as I mentioned, more of a problem than a solution, and the methodologies that will solve that problem involve all of the current methodologies. So reinforcement learning and deep learning are going to be part of that solution. The optimal place for that in terms of application is going to be in robotics, but that doesn't mean that robotics is the only place where it can be used. Anytime that there's a process that's extremely complex and a lot of knowledge has to be built up in order to manipulate or control that process, then continual learning methods are going to become more interesting. We're seeing this already right now because it can be done so well in healthcare through physician expertise. So if we have a wound, for example, or there's a bump or something on your skin, then suddenly now we can take a picture of that, and neural networks can start to do diagnoses based on just those images. But in the real world, most things require more than just a picture. If you really want to do a real physical examination, for example, that requires an interactive procedure. You have to be able to interact with people. Most other expertise also involves interaction. Say, for example, you want to know, is this a ripe avocado or not? Is this a good piece of fruit? Is this a well-made chair? There are people who know the answers to that, can answer that really well. And if you knew them, you'd ask them before you bought it, right? But that sort of expertise is not available to us, and it could be. It could be in the hands of normal people, so that they can ask a question of their smartphone and get really good expert answers on nearly any topic. Just a normal, everyday, average human can teach his or her robot to do something new, and then teach it to do something a little bit more complex based on that. That will be the measure of having really succeeded. We can really do that. That will be the door opening to a huge change. So I think one of the most interesting things that we're seeing, and the reason that we're seeing, this goes back to your earlier question, Why are we seeing so much interest now suddenly in continual learning? It's because so many of the harder, more fundamental problems have been solved now. People are willing to think of neural networks and deep learning algorithms as solutions, as tools for their toolbox. They don't have to think anymore about what would be a better neural network, how can we make it a little bit, I mean, people certainly do still think about that, but we understand now, society, the AI community has a feeling now for what can and can't be done with these tools. In the same way, I think that what we're going to see in continual learning is we're going to have learned how to do certain things that will allow us to talk about more complex things. So right now, we still don't know how to encode a skill. We don't really know how to encode knowledge. Well, we do, but only a few people on the cutting edge kind of get how this is going to work. As that becomes more popular, understood, these solutions, people are going to say, well, that problem's solved. I know how to do skills. I know how to encode knowledge. Now what am I going to think about? Now it's going to be raised to a higher level. It's going to say, well, you know, what are the skills that I want to be able to learn? What is the knowledge that I want to learn? How do I know that? You know, how do you motivate an agent to do things? How do you talk about that, right? So these other problems will have been solved. So in 10 years, I expect that we're going to be working on sort of upper layers of intelligence, things that we aren't working on now, but we recognize in humans exist. They're going to come after. What if you have an agent that can develop skills and knowledge? Now what? You know, what else do you have to worry about? You have to worry about its socialization. You know, how does it get along with other agents? Things like that. Maybe not quite that far in 10 years, but it'll be higher levels of intelligence than that we're currently concerned with. Right, there are two major ways that we're different from DeepMind. One is our focus, and the other is our commercialization. So DeepMind is fundamentally a research organization, and they've been very, very successful that way. They've attracted tons of the brain power in AI, especially the brain power of reinforcement learning and deep learning. But they don't do a lot with commercial applications. They do have a commercial applications arm, but it's not fundamental to what they do. There are other companies, AI companies, where commercialization is fundamental to what they do, and they do less research. They tend to have a lot fewer researchers on staff, and they're not really trying to do a lot of research. So the way we're different is that we do both commercialization and research, and we're focused on the continual learning problem. So as far as I know, there are no other companies in the world who are focused specifically on the continual learning problem. There are very few, if any, AI companies in the world that are equally devoted to both commercialization and to research.